Hello. So today this is the third episode of my cryptography videos, and what I'm going to be going over today is called a polyalphabetic cipher, and this one is really the start of modern cryptography, I would say, in my opinion. Basically what a polyalphabetic cipher is it's a series of monoalphabetic ciphers, and what you do is you use a keyword, and then for each letter on the polyalphabetic cipher, what you do is for the keyword, that corresponds to a certain monoalphabetic cipher that you will use for a certain letter of each ciphertext. So, let's get started.
Alright, so, as I was saying, this is what's called a Vigenère square. And basically what a Vigenère square is if you look here, we've got the alphabet written out on the first line, and then on the next line we've got the alphabet written out, starting with the letter B, so B, C, D, E, F, G, and then at the end we add the A. So basically what we're doing is we're shifting the alphabet one letter to the right as we're going down this column, and we're just adding the remaining letters to the end. So all the way at the end here we've got Z, and then A, B, C, and the alphabet all the way through to Y. So that basically continues down, and what this is a one Caesar shift cipher, a level 1, or a one shift Caesar cipher for every letter in the alphabet. Okay, so, or a Caesar shift 0, 1, all the way to Caesar shift to 26. So, how does this cipher work? How do we go through and how do we actually do this? Well, this is one of the first ciphers that I know of that has a code word, and basically what a code word is we pick one word that we're gonna use through our message. So, for example, let's use the code word badger. Badger. Okay. Now, this is our code word, and this is something that we would send to, we would have to somehow get to our intended recipient safely. Now, let's encrypt some ciphertext with it. Let's use the name Sydney. Okay, S-Y-D-N-E-Y, Sydney. Okay, so what we want to do is for each letter in our code word, we want to go and we want to find the resulting row in our Vigenère square, and then for our ciphertext, we want to go and we want to find the corresponding column, and then go and look up what the plaintext alphabet would be. So, for example, for B, we would go to row B, and then we would go to row B, and then we would go to column S, and the resulting one would be R. And then we would go to row A, and then find Y, and the resulting one would be Y. And then we would go to row D, and find D, and the resulting one would be A. Okay? So now we would continue this, and we would end up with something that looks like this. So RYAHAH. Now, the interesting thing about this is that this sort of cipher doesn't work with the typical numerical analysis that we did in the last video. So when you look through it and you compare it to the number of letters that's used in a sentence and then correspond it to what it should look like, and then shift the cipher to work like that, this one doesn't work. You have to use a different method to figure out the ciphertext. You have to use a different method to figure out how to crack this cipher. So why is this cipher more secure than a simple Caesar shift or a monoalphabetic cipher? Well, in a simple monoalphabetic cipher, you've got the letters A through Z, which is 26 letters. Okay. And now for each shift, we've got a shift of 1, so that means that we can have 26 factorial choices that we can use. We can shift between 1 and 26. So basically this means that we've got only 26 different chances. We've got 26 factorial, so that's 26 times 25 times 24, and so on until you get to times 1. So this here, right here, is the amount of keys in a normal single Caesar shift cipher. Now, in this cipher, we've got a different possible Caesar shift for each letter of our key. So what that means is that if our key is 6 letters long, then we've got 6 times 26 factorial. So that ends up being 26 factorial, sorry, it won't be 6 times, it'll be 26 factorial times 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 26 factorial. So basically 26 factorial to the power of 6, basically, is what you'd be looking at there for this particular Vigenère cipher. And as you can see, this number is large. It would take a long time to do by hand, a lot longer than most people would expect if you didn't use if you didn't use the cracking method that I had discussed in the earlier video. But this key takes exceptionally longer, so much longer so that back in the days before computers existed, this was essentially uncrackable. Except it was crackable. And we will go over that in another video. If you like this video, remember to give it a thumbs up and subscribe to me, because there's always new videos coming out about cryptography or biology, anything that you could possibly imagine. So what are you waiting for? Do it.